Good morning, my dear students. My name is Palaj Biswas, Assistant Professor, JS College of Engineering, Department of Mechanical Engineering. And this is my lecture number 9 under the subject of computer aided design. And we can discuss today the viewing transformations. And transformations, because there are often many different possible coordinate systems for describing geometrical figure. And the geometrical figure, it is important to understand how they are related, and such relations are described by coordinates transformations, which give formulas for the coordinates in one system in terms of the coordinates in another system. Basically, you have to transfer your coordinates, the one place to this the another place. That like your the one coordinates to this the another coordinates, and also your reference plane also will be transferred during toward the different place, and these systems will be here. And just like is considered the coordinate systems is in terms of these coordinates in another system. For example, in the plane, if Cartesian coordinates is the x y is considered, and polar coordinates is the considered the r theta, we have the same origin, and the polar axis is the positive x-axis, then the coordinates transformations from polar to Cartesian coordinates is given by that like your the equation x equals to r cos theta. You have to putting this the theta value, and this transformations also will be done in or the physics, and also the in our the mathematical considerations will be transfer that like your the previous classes also. And also the r cos theta and y equals to r sin theta, and this will be calculated from this the different transformations also will be found that like your the Cartesian coordinates to this the polar coordinates we can be calculated very easily. And also this will be putting this value, the theta r, and also you have to find out this x, and sometimes you have to find the putting this value x and r, and also you have to calculate the theta value. And this is the very easily you can be calculated during the transformations. And during to these transformations you have to find the this is the translations will be found like the moving the grid, and the reflex you have to moving this grid. And you can see that this different type of pixels will be considered according to this the computer added or this CAD. And this computer graphics or this pixel, we can see that like your the square, and this is the different grid is used, and these grids will be transferred or this moves from the one place to this the another. And during to this grid you have to consider the different the code rect also will be here. You can see, as you know, your processing window works like a pieces of graph paper. That's like your the processing window in your computer. You can see this like a pieces of graph paper. That's like the square graph paper is here. And when you want to draw some things, and you can be want to draw some things, you specify its coordinates on the graph, and that like your the coordinates on the graph. Here is a simple rectangle draw with the coordinates that like your the 2020 and also the 4040 you have to consider according to your the simple graph papers. The coordinate systems, a fancy word or for graph paper, is showing in gray. You can see this is a gray that like your the um, uh, your window. You can see that like is the this grid also will be the grid is the also the move during to this here, and the showing here. And this that's like if you want to move the rectangle, and you can see that this type of grid that like your the rectangle 60 units, a rectangle 60 units right, and the 80 units down. You can see that this like your the windows and the different the graph paper. You can see that this like is also concentrate according to your the movements units, that like the one is the right as well as is the down. You can just change the coordinates by adding to the new the x and y starting points. The you have to see the coordinates by adding to the x and y static points, that like the rectangle 20 plus 60, the 20 plus 60, and also the 20 plus 80, and 40 plus 40 is considered according to this. The movement is consideration according to this, your the coordinates will be changed. That like the 20 plus 60, 20 plus 80, and also 40 40, and the rectangle will appear in a different place, and this will be appear in the different place. We put the arrow in, therefore dramatics effects also will be find the consideration according to this, the appear in a different place. You can see that like your this figure you have to consider according to this, the first grid to your the last time the shadow graded will be given to this the notations, that like the red arrow will be given, just like this the movement of grid from this the first phase to this the final phase. You can see the, but there is a more interesting way to do it. The more interesting way to do it, you can see, move the graph paper instead. Move the graph paper instead. Also will be the not will be the grid will be moved, and that like is the move the graph paper instead. If you move the graph paper 60 units, the move the graph paper is the like the 60 units right, and the 80 units down. You can see this like your the 60 unit rights and the 80 units down you have to send. Previously also will be considered according to this, that like your the 60 unit right and the 80 units down. The similarly the 60 unit rights and the 80 units down also will be considered. You will get exactly the same visual result, but the you will exactly get the same visual results. Moving the coordinate system is called the translations also only. That this is the called this type of moving the coordinate systems is called the translations. And the important thing to notice in the preceding diagram is that as far as the rectangle is concerned is it hasn't moved at all. Its upper left corner is still at 2020. When you use the transformations, the things you draw never change positions. The coordinate system does. Basically, this will be concentrate according to this. The diagram is that the as far as the rectangle is concerned, it hasn't moved at all. Its upper left corner is still at 2020. There is the no change. When you use the transformations, the things you draw never change positions. That's like you the never change positions. The coordinate system does. And another things, here is code that draws the rectangle in red by changing. That's like the red by changing its coordinates. And during to this, that like your the coordinate is changed. Then draws it in blue by moving the grid. That's like you are the moving by grids from this the first phase to this the last year since this position, and also this grid is the moving. The rectangles are translates so that you can see that they are visually, basically they are visually at the same place. Only the method used to move them has changed. Basically this method is the move them has changed. The copy and paste in this code into the processing and give it a try also will be during to this the movement of this grid. Just like you have to given the blue the blue grids, moving grids, and another things also will be visually the at the same place. Only the methods used to move them has changed. Copy and paste this code into the processing and give it to a try. And comes on this the viewing transformations. The viewing transformations is the mapping of coordinates. Mapping of coordinates, that means the different type of coordinates also will be recorded for this the mapping. And again the points and lines that forms the picture into appropriate coordinates on the display device will be find during to your the viewing transformation. That means the you have to concern your the display device also will be essential. That's like your the monitor. Monitor is considered according to the display device, the which is the picture and appropriate things also will be seen during toward the display. And similarly, this mapping codings point and the lines that from the picture into appropriate coordinates on the display device is found. And the world coordinate system, that like the WCS, is the right-handed. The world coordinate systems is the right-handed Cartesian coordinate system where we define the picture to be displayed. The basically this coordinate system is the here that like you the define the picture, the also the to be displayed, the where is the will be displayed is defined, that's like you will be considered according to your the world coordinate systems. And another things, a finite region in the WCS, that like the world coordinate system, is called the window. And each and every computer have a window, and the during depends on this the window. This is the considers for the viewing transformations also. And during to this the window is that like your the define the picture, and also this like is picture is required for the display on this picture. And during to this window is not proper works in this computer, but your the system is not run properly, and also your the picture is not properly viewing or the display on this the monitor. And the corresponding coordinate systems on the display device where the image of the picture is displayed is called the physical coordinate systems is here. That like your the corresponding coordinate systems on the display device where the image of the picture is displayed is called the physical coordinate system. And another thing is here, mapping the window into a subversion of the display device called the viewpoint. Viewpoint is called the viewing transformations. The normalized device coordinates, that means is the NDC, is the display area of the virtual display device coordinating corresponding to a unit square is considered is here. Like your the normal device coordinates, that like your the NDC is the display area of the virtual display device corresponding to a unit square. The lower left hand corner is the origin of the coordinate systems, mapping the windows and in the world coordinate space to view parts in NDC space is called the normalization transformation, that like is given the N is the normalization transformations. You can see here where the N equals to the given this the matrix is here, that likes your the Sx is suffix s, and also the first row is here, that like the 0 0, and second the first column is considered equals to xs 0 0, and the second column is here the 0 xy and the 0, and x v mean is minus the sx, the x w mean is here minus SY, SYY, W mean plus YV mean and 1. This like is the considered according to this matrix. And from this matrix we have to putting here where the SX and SY is the scale in X and Y directions given. And basically the SX and this normalization, that is the previous slides you can be slide is the discussion according to your the normal transformation, that like the N is because right here during to this the on matrix is given, and also the Sx and Sy is the scale of x and y, and this value will be given here. The Sx equals to x b max is b max minus x b min, and also the x w max minus x w min. This will be the value of the x is Sx is the calculated, just like your the x direction, the s value will be found, and also putting this the normalization transformations. And you can see here the Sy equals to y v max minus the y v min, that likes your the divided by the y v, w max minus y w min is calculated, just like your the Sy value. and during to this the sx and sy, you have to putting this the normalizations, the matrix that like your the sx xy and also the x b mean, and this value will be calculated this here. The view transformations, a 3D sense can be viewed from any positions in 3D space. Basically, this view transformation that like your the 3D sense can be viewed from any positions in the 3D space, and a synthetic camera positions and orientates in 3D space can be used to describe the viewing, and the part of the image or sense to be viewed is here. Just like your the 3D space, and also the synthetic camera is positioned, and also the orientations will be required during to this the 3D view transformations, and this will be can be used and described, and also required for this the viewing of this the object, and either, and also this the part of this the image or the sense of viewed, and which image you can see that like your the this is the display, and also your the windows, this is the display to this the systems, and it has the following three principal three principles is available is here, that like your the view plane is here. The basically the which the window is defined in this plane. The origin of this plane which defines the positions of the eye or camera is called the view reference point also is here. That like your the you have to concentrate according to your the eye, and as like as the camera, and this is the considered according to your the view reference is here, and during to this consideration is called the view planes. And another things is here, a unit vector to this plane is the view plane normal, that like your the n n is considered according to this the n vector is find out the normal vectors, that like your the unit vector to this plane is view plane is the normal. Another vector called the viewpoint, that like the bwp is considered according to this the view of vector is a unit vector perpendicular to, that like your the this unit vector is the perpendicular to this is considered according to your the view planes, and during to this one you have to consideration according to this the transformations. You can see here the view coordinate systems, the usually left-handed systems can called the UVN system is used. That like your the UVN system is used. The y-axis of the view coordinate system is perpendicular projection, that like use the of the VWP on the viewpoints is the calculated. Now during to this the UVN system is used, and the y-axis and the view coordinate system is the perpendicular projections of VWP of on the view planes, and the VJ, the x-axis of the view coordinate is orthogonal to n vectors, and that is the v vectors is equals to u vectors equals to b vector into n vectors. That like your the is considered according to this the u and v is the positives, and at the right and up directions from the I point of view is considered is the z-axis of the view coordinates, that like your the x-axis and z-axis is considered according to your the view coordinates, and also this it increases in positive directions with depth of points from the eyes will be considered according to your the viewpoints. That like your the eyes where is the concern is here. You can see here the from this the eye, and eye defined within this system that like your the n dash and e determines a plane orthogonal to, that like to containing e. Let a equals to ax ey and ez is here be the look at points. For perspectives views, the view plan normal as a unit vector from I to a look at point is given by, that like use the n vectors equals to 1 by mod a minus e double mods, that like you have to given here the bracket start az minus ez ex ay minus ui, az minus ez. That like your the equation is fine. And another thing is the a minus e is calculated equals to under root of as x minus ez is whole square plus ay minus ui whole square plus az minus ez whole square is you have to calculate the value of a minus e. The view of vector is the tilt rotations of the head or camera. For parallel view, it is convenient to think of the view plane normal as determining the direction of projections is here. View coordinate system is here. The discuss about this the view coordinate systems. An object in world coordinate space whose vertex are x, y, z. It will be here that like your the vertex is the x, y, z can be expressed in terms of view coordinates u, v, n is here that like your the translate the view reference point e to the origin. The can be expressed in terms of view coordinates that like your the uvn, and also the translate the view reference point into the origin. Rotate about world coordinates y-axis to bring the view the because you're the about the world coordinates y-axis to bring the view coordinates n n vector axis into the yz plane to world coordinates is considered according to this the view coordinate systems. You can see here the rotate about the world coordinates x-axis. You need the z-axis of both systems are aligned. Aligned that like the rotate about the world coordinates z-axis to align the v vector, align the v vector axis with the y, reflects relatives to the xy plane, reversing signs of each z coordinates to change into a left-handed coordinate system is given here. The viewing transformations is the v equals to t into r bracket start is the y and the rx and rz into the f will be considered according to the viewing transformations equation is here. The example of view transformations will be given here. Let on. This like the three coordinates, the x, y, and z coordinates will be considered be the view reference points. Let 0, 0, 0 be the look at points is here. The let 0 on 0 be the up vectors that like the translate the 1, 0, 0, 1, 1 and also the second column is here the 0 on 0 minus 1, and also the third column the 0 0 1 minus 1, and also this fourth column 0 0 0 1. And rotate by about y, the rotate about y is considered the root over 2 by 2. The this is the first column is here the 0 minus root over by 2 minus root over 2 by 2, and the last one is the 0, and the second column is here the 0 on 0 0, and the third column is here root over 2 by 2, the 0 root over 2 by 2 0, and the fourth column is here the 0 0 0 1 is considered according to the rotate about this the y axis is consideration according to your the example of view transformations. The rotate about the x, the rotate about this x is considered the 1 0 0 0 is the first column. The second column is the 0 under root of root 2 by root 3, and the minus 1 by root 3, and the 0 is the second column is completed, and also the third column 0 1 by under root 3, the root 2 by root 3, the 0, and also this is the fourth column 0 0 0 1 is considered according to this the rotation about this the x-axis. And another things the rotate about the z, that like your the identity reflections will be found during to this the this is the on components. You can see that like your the matrix is given the column the one first column is the 1 0 0 0, and the second column 0 1 0 0, and the third column 0 0 minus 1 0, and also this is the fourth column, the 0 0 0 1 is here. About the, this is the rotate, about this the z is the identity reflection is here. And another thing is the composite transform is the v will be considered according to this the first column, the root 2 by 2, the 0, and also minus root 2 by 2 0, and minus 1 by root 6, the 2 by root 6 minus 1 by root 6 0 is here. And the third column minus 1 by root 3, second one is the minus 1 by root 3, third one is the minus 1 by root 3, and by and also the fourth one is the root 3, and also the value to this the fourth column, the 0 0 0 1 will be consideration according to this type, this matrix that like is considered the composite transform, and the vertex is here. And another, it is seen the to perform sequence of transformations such as translations followed by rotation and scaling, we need to follow a sequential process that like use the minus 1 translate sequential process, just like the one is here that translate the coordinates, and the second is here the rotate the translate coordinates, and then the third is considered according to the scale the rotate coordinates to the complete the composite transformations is consideration that like your the basically the three type of transformation is considered according to the translations, rotations, and also the scale. And this is the three one will be considered. And another things will be here to shorten his process. This process we have to use the 3 into 3 matrix, and that like your the transformation matrix, the instead of 2 into 2 transformation matrix is considered, and to convert a 2 into 2 matrix to 3 into 3 matrix will be very easily for your the transformations, also the composite transformations. And the current transformations matrix that like your the CTA is given here. The conceptually there is a 4 into 4 homogeneous coordinate matrix is available in your the current transformations matrix, and this current transformations matrix is the CTM that is part of the state and is applied to all vertices that pass down the pipelines. The pipelines is here. Thus current transformation matrix is defined in the user program and loaded into a transformations unit is here. That like your the you can see here that like the current transformation matrix is given, and the first one is the vertex, the arrow is given to this the P, and this is the down from this the downward direction is here that like the C, and vertex is here the P equals to CP is considered according to the current transformation matrix. Few application is considered according to the viewing transformations. The viewing transformations has lots of controls, but typically they are not all used together is considered. And another things the rather a couple important control are set and the rest are let the default to their logical values. The viewing transformations can be broken down into two pieces, the camera to screen projection and the screen to raster projection is here. The viewing transformations converts object from their three-dimensional camera space coordinate into the appropriate two-dimensional raster space coordinates is considered according to this the applications. The camera coordinate system is a coordinate system which the with the camera at the origin looking out over the positive z-axis is here. It is essentially the sense from the camera's point of view. The raster coordinate system is the space of the pixel of on the monitor. The connecting the these two coordinate systems, there is a special coordinate systems known as screen coordinate systems. The screen coordinate system is conceptually the same as the film plane of a camera. it is usually best to consider both the screen coordinate systems and raster coordinate system to be two dimensions. Even through the we know that the render man can output depth information. The renderman interface specifications has a rather complex viewing transformations. The interface has many cores with each set of small pieces of the transformations. Each of these values has a reasonable default, which is to say that if you don't set it, it will default to something which is probably appropriate given the values that you have already set. And you can see the viewing transformations have lost of control, but typically they are not all used together. Either a couple important control are set in this the rest and the default the logical values. You can see the camera to screen projections flatted the 3D world into this the 2D screens. The screen the raster projections maps every points on the screen on some output pixel will be here. And next class we introduction to this the discuss about this the geometric modeling. Thank you, student.